Hi everyone, myself Pratham Tyagi. I'm an application engineer at Ideas Design Solution. In today's session, we will explore how to effectively use advanced assembly mates and the mate controller in SolidWorks to create smooth and controlled motion, especially for a 5-axis robotic arm. By the end of this video, you'll understand how to set up mates, control complex movements, and finally create a clean animation without running into over-defining issues. So let's start by looking at some advanced mate option in the assembly module of SolidWorks. We'll mainly focus on limit angle mate and limit distance mates. These mates are extremely useful when you need to restrict the range of the motion of moving parts, just like a real world joint or actuator that can only move between specific limits. For example, in our case, our robotic arm assembly, the limit angle mate helps us define how far a particular link can rotate, say between 0 to 100 degrees. For this specific case, I have used this limit. Similarly, the limit distance mate helps control linear motion like the extension or a retraction of a slider or the actuator. By defining these mates carefully, we will make sure each joint behaves as it should, neither going beyond its physical range nor moving unpredictably. So we will use these kinds of mate, especially advanced mate, for defining the motion of our assembly. So let's see. So let's apply these mates to our 5-axis robotic arm. I'll start by selecting the base and the first link of the arm, applying an angle limit mate to control its rotation. Then I'll use a distance mate to restrict the motion of the next section. And this is how you can see or you can use each mate in your specific robotic arm or in a arm related to the movement of the robot.
If you enjoyed this content, make sure to subscribe to our channel right here.
So as per your requirement, you can change the angle. As I have used some specific limit, you can obviously change the limit of the angle and you can change the alignment of the angle. You can see how each axis of motion is now constrained as per our requirement. This ensures that when we later add movement or animation, everything behaves realistically. Once all required mates are applied, test the motion using the move component command. If it moves smoothly within the limits you define, it means the mates are correctly applied. Now that's our mate. That was our mates part. Let's move to something more powerful. It's the mate controller tool. You can easily find it by searching over here in the search command. You can also activate it from the assembly tab by going into the customize assembly tab. Now after switching on the mate controller lets us define multiple positions for our assembly using the existing mates and then animate the transitions between them. It's especially useful for mechanisms like robot, linkages, sliders, or even suspension systems, anything that involves sequential movement. So we will be using this mate controller for the motion of our robotic arm. Before we start creating positions, let's also enable the drive mate here in the mate controller tab. Once the mate controller is active, you can set certain mates as driven, meaning their values will be controlled by the mate controller instead of being fixed manually. This feature gives us precise control over how each mate behaves in each position, like the angle of a rotation or the extension distance. So you can use this driven mate command and you can manually set the other positions. So we'll now use the driven mate command for each mate supported by the mate controller tab. This helps us in keeping the animation smooth and coordinated. Now coming to the interesting part, which is creating the positions. We'll start by defining the initial position of our robotic arm. Let's call this home position. Next, we will create the second and third position by slightly adjusting the mate value, or you can manually change the position of the robot. In this case, we are using this command on robot, so we'll manually change the positions of the robot. For example, moving the arm upward, rotating a joint, or extending a link. Each position usually has a duration of around 2 seconds. In this case, I have created around 13 different positions, I may say, each showing a small realistic movement of the arm. Once all positions are created, we can play the full motion after making it calculate the complete set of position in a sequential manner using the play button in the mate controller here. Before finalizing, it's very important to set the initial boundary condition. This means defining the limit or range of each motion, like minimum and maximum angle or the maximum distance. If we skip this step, the assembly can easily become overdefined and cluttered, resulting in jerky or incorrect motion paths. This is one of the most common mistake when using mate controller for animation. By defining these boundaries properly, we maintain a clean workflow, which helps us reduce error and make sure that our animation behaves exactly as intended. Once you set up this much boundary conditions, and if you set up the driven mate command, you can export this entire sequence of the motion study timeline for rendering or video creation. The mate controller's optimized workflow helps avoid a repetitive key point issue you might face in manual animation setup. This not only improves your animation quality but also boosts efficiency when working on multiple design iteration or working on such the sequential motion analysis. So that was it, and that's how you can easily use assembly mates and the mate controller in SolidWorks to precisely control the motion and create smooth and realistic animations, just like a real robotic system. I hope you found this tutorial helpful. If you did, don't forget to like, share and subscribe to our channel for more SolidWorks related content. Thanks for watching.
Do subscribe our channel and hit the bell icon.